Ever feel like you're wading through a swamp when you try to fix someone else's code?
Oh, tell me about it.
I remember this one project, I was on a crazy deadline,
Yeah.
and the code was just a mess. Variables named like X and temp, you know?
Oh, yeah, classic.
It was like trying to read a foreign language, only worse.
The joys of deciphering cryptic code. It's a tale as old as time in software development.
Isn't it? And that's exactly why we're diving into Clean Code by Robert C. Martin today.
Clean code. A classic for a reason.
Right. I mean, you shared some excerpts with me.
Yeah.
And I gotta say, this book feels like the Rosetta Stone for writing code that doesn't make you want to tear your hair out.
It's true. It's not just about making your code look pretty. It's about building software that lasts, that's easy to understand, to maintain,
Right.
adapt it when you need to.
Exactly. We've all been there, right? That code that seemed fine at first, but then you have to go back and change something.
Oh, yeah.
It's a nightmare.
Becomes a real mess.
So how does Martin approach this idea of clean code? What's his secret sauce?
Well, he uses these really cool metaphors to get his point across. Like, he talks about how reading clean code should be like reading a newspaper.
A newspaper. Okay, now I'm intrigued. Tell me more.
Well, think about it. When you read a newspaper, you don't start on page 1 and read every single word, right?
No, definitely not.
You skim the headlines,
Right.
you get the gist, and then, if something catches your eye, you dive into the details. Well, good code is kind of like that.
Okay, I see where you're going with this.
Right. Those headlines, those
Yeah.
are your functions, your class names.
Mhm.
They give you the big picture.
So you can quickly see what's going on without getting bogged down in the nitty-gritty.
Exactly. And if you need to drill down into the specifics of how something works, you can dig into those functions, those classes.
That's a really good analogy. It makes perfect sense.
Right.
Because we don't read a newspaper from cover to cover. We're looking for what's relevant to us.
And that's exactly what you want to be able to do with a good code base, right? Easily find what you need.
Absolutely. And it makes it easier for others to understand your code, too.
Oh, absolutely. Collaboration is key in this field.
So clean code helps us avoid those major development headaches down the line.
It really does. When your code is clear, well-organized, it's so much easier to add features, fix bugs, all that good stuff.
Right, because requirements change all the time in software development.
All the time.
Mhm.
And if you're constantly fighting with messy code, it's going to slow you down, lead to mistakes, frustration.
Oh, for sure.
And in the long run, it can cost companies a lot of money.
Right, because time is money, as they say.
Exactly.
So clean code, it's like an investment in the future of your project.
It really is. And one of the best investments you can make is embracing this idea of the Boy Scout rule, as Martin calls it.
Okay, the Boy Scout rule. I've heard of this. Remind me again what that is.
It's simple, really. Leave the code a little cleaner than you found it.
I love that. Such a simple concept, but so powerful.
Right, like if everyone on the team commits to cleaning up even a small part of the code base every time they work on it,
Yeah.
those small improvements, they add up over time.
It's like the broken window theory, but in reverse. Instead of letting small problems fester, you're actively making things better.
And it can have a ripple effect.
Yeah.
You start cleaning up your little corner of the code base.
Yeah,
Other people see that, and they're more likely to do the same. Creates a culture of quality.
I like it. So we've talked about metaphors, the Boy Scout rule, all great stuff, but where do we actually start? What are some concrete steps to writing cleaner code?
Well, Martin talks a lot about the importance of good names.
Good names. You mean like variable names, function names, that sort of thing?
Exactly. It might seem like a small detail,
Yeah.
but trust me, it makes a world of difference. Martin actually compares choosing a variable name to naming your firstborn child.
Wow. Okay, no pressure then. I've definitely seen some questionable variable names in my time.
Oh, I'm sure you have.
Data is a personal favorite. Like, what kind of data? Tell me more.
Right. Generic names like that, they don't tell you anything about what the variable actually represents.
Right.
Martin's big on intention-revealing names. You should be able to look at a variable name and instantly know what it holds, what its purpose is.
So instead of data, you'd have something like customer order history or product inventory count.
Exactly. Those names tell a story. They make the code self-documenting.
It's like the difference between having a well-labeled map and a hand-drawn one with scribbles all over it.
Perfect analogy. One makes navigating a new city a breeze, the other a headache.
And no one wants a headache when they're trying to understand code.
Exactly. And the same principle goes for function names. Instead of using vague verbs like process or handle,
Yeah.
go for something more descriptive.
So instead of calculated data, you'd have something like calculate monthly sales report or format customer address.
Now you're getting it. Clear descriptive names, they act like mini documentation.
And that means less need for separate comments, right?
Exactly. The code becomes self-explanatory.
Right.
And Martin is not shy about calling out bad naming practices.
Oh, really? Does he have any good examples?
He talks about this one developer who used the name class instead of class, just because class was already being used for something else.
Oh, no. Talk about confusing.
Right. Those kinds of workarounds might seem clever at the time, but they just make the code harder to understand in the long run.
So clear, intention-revealing names are key. And it sounds like this applies to more than just variables.
Absolutely. Martin also stresses the importance of well-named functions.
Yeah.
But it's not just about the names themselves, it's about how those functions are structured, how they're organized within your code.
Okay, I'm listening. Tell me more about how to write cleaner, more elegant functions.
It's like you're reading a good book, right?
Yeah.
The story flows,
Right.
one thing leads to the next, it's all connected. Martin says well-structured functions, they should be kind of like that.
So you're saying our functions should be like little stories within the larger narrative of our code.
Exactly. Each one should have a clear purpose, a single responsibility. He calls it the one thing rule.
The one thing rule. I like that.
Yeah. If you've got a function that's trying to do a million things at once, time to break it up.
Right. Because those massive functions, they can be intimidating.
Trying to understand one of those is like, I don't know.
It's like trying to untangle a giant ball of yarn.
Exactly. And when it comes to fixing a bug in one of those, good luck.
It's a recipe for disaster, right? You change one tiny thing, and suddenly something completely unrelated breaks.
Been there, done that. Not fun.
So breaking things down into smaller, more focused functions makes our code easier to understand, easier to maintain.
And easier to test, which is super important.
Absolutely. Speaking of testing, Martin has some pretty strong opinions about comments, right?
Oh, yeah. Comments. They're a bit of a touchy subject, aren't they?
It's like everyone's got an opinion on how to use them, when to use them, if you should use them at all.
Right. Martin calls them a necessary evil. He'd rather see code that's so clear, so well written, that comments become unnecessary.
I can see that. It's like if you have to explain a joke, it's not that funny anymore.
Exactly. And sometimes comments just add more noise, more clutter, you know?
So if you feel like you need to write a comment to explain what your code is doing, it's probably a sign that the code itself isn't clear enough.
Bingo. Refactor, don't comment. That's his motto. He's got this great line. Don't comment bad code, rewrite it.
Love it. So does that mean we should never write comments?
Not necessarily.
Yeah.
He does say there are times when they're useful, even necessary. But those should be the exception, not the rule.
Okay, so when are comments actually a good idea?
He suggests using them to explain the why behind a piece of code rather than the what.
So instead of stating the obvious, like this function calculates the total price, you'd use a comment to explain why you chose a particular algorithm or why you structured the code in a certain way.
Now you're getting it. It's about adding value with your comments, not just repeating what the code already says.
Context over repetition. Got it. So we've talked about functions, comments. What about refactoring?
Refactoring. It's like hitting the refresh button on your code.
Okay, I like that. Tell me more.
Imagine your code is a garden. Right?
Yeah.
Over time, weeds can sprout up.
Sure.
Things get overgrown, messy.
Yeah, I can see that.
Refactoring, it's like tending to that garden. You're pruning back the dead weight, reorganizing things, making it all nice and tidy.
So it's not just a one-time thing, it's an ongoing process.
Exactly. You don't wait for your garden to become a complete jungle before you start weeding, right? Same with your code.
So small improvements made regularly.
Got it. Even little things like renaming a variable to be more descriptive or extracting a few lines of code into a separate function, those small changes add up over time.
It's about making things a little bit better every time you touch the code.
And don't forget about tests. Martin's a big believer in having a good set of tests to back you up when you're refactoring.
Right, because if you're making changes, you want to make sure you're not breaking anything in the process.
Exactly. Tests are your safety net. They give you that confidence to refactor knowing that if you do accidentally introduce a bug, those tests will catch it.
So what's Martin's take on error handling? It's one of those things that can really make code messy if it's not done well.
Oh, absolutely. He talks about how important it is to handle errors gracefully.
Gracefully being the key word here, because I've seen some pretty ungraceful error handling in my time.
It's like trying to follow a recipe where the instructions are scattered all over the place, and some of them are written on napkins.
Been there. It's not pretty. So how do we bring some grace into our error handling?
Well, Martin's a big fan of using exceptions.
Exception.
Yeah, instead of having if statements checking for errors all over the place, which can really clutter up your code.
Right. It's like those choose your own adventure books, but for code. Not always the most enjoyable reading experience.
Exactly. Exceptions provide a cleaner way to handle those what if something goes wrong scenarios.
So you're saying use try-catch blocks to encapsulate our error handling logic.
You got it. That way, the main flow of your program is clear and easy to follow. It's like, this is the happy path. This is what happens when everything goes according to plan.
And then the catch block is like, okay, something went off the rails here. Let's deal with it.
Exactly. He calls it defining the normal flow.
Defining the normal flow. I like that.
Make the happy path clear and then handle those edge cases, those error conditions, separately.
It's about separation of concerns, keeping those error handling details from obscuring the main purpose of the code.
Exactly. And he emphasizes that even those error messages, they should be informative.
Oh, yes. No more vague and error occurred messages.
Right. Give the user or the developer enough information to actually diagnose and fix the problem.
It's like leaving breadcrumbs instead of just a single cryptic signpost in the middle of the woods.
Perfect analogy. Clear, informative error messages, they're a lifesaver when you're trying to track down a bug.
They really are. Okay, so we've covered error handling. Now let's talk about something else that can cause a lot of headaches. Null values.
Ah, yes, null. The billion-dollar mistake, as it's sometimes called.
Rightfully so. I feel like I've spent countless hours of my life debugging null pointer exceptions.
We've all been there. Martin's not a fan of nulls. He sees them as a source of ambiguity and a breeding ground for bugs.
So what's his solution? How do we deal with those situations where a value might not exist?
Well, he suggests a couple of alternatives. One option is to throw an exception, like we were just talking about. It's a way of explicitly signaling that the requested value isn't available.
So instead of returning null if, say, a database query doesn't return a result, you'd throw an exception that says something like record not found.
Exactly. Makes your intent crystal clear. And then he talks about this other interesting idea, returning a special case object.
A special case object. Okay, now I'm really curious. What's that all about?
So let's say you have a function that's looking up a customer record. Instead of returning null if the customer isn't found, you could return a null customer object.
Okay, so it's like a placeholder, a stand-in for the actual customer object.
Exactly. It doesn't contain any real data, but it lets your code keep running without crashing. You can even give this null customer object specific behaviors, so it knows how to act in different situations.
That's fascinating. So instead of just having this void, this null, you have an object that represents the absence of a value in a more meaningful way.
Exactly. It's about being explicit and intentional with your code. Don't just reach for the easiest solution. Think about the cleanest, the most expressive way to represent what you're trying to do.
I like it. It's about being thoughtful about every aspect of your code. Okay, so we've talked about error handling, null values, all crucial stuff. But what about when we're working with external code, like libraries or frameworks? Those can be a bit tricky to integrate cleanly. It's like you're trying to force a square peg into a round hole sometimes.
It definitely can be. Martin talks about these areas as boundaries where your code interacts with this external code. You got to create clear separation.
Boundaries. Okay, interesting.
Yeah, you don't want those external libraries dictating the structure of your entire code base.
Right, you don't want to be at the mercy of some third-party library that could change at any moment.
Exactly. He talks about wrapping those external APIs with your own interfaces.
So creating like an adapter layer, something that speaks both the language of your code and the language of that external library.
You got it. Acts like a buffer.
And that way, if that external library changes, you only have to update that adapter, not your whole code base.
Exactly. Saves you a ton of headaches down the road. It's like having a universal adapter when you travel.
Ooh, I like that analogy.
All right. You don't have to rewire all your electronics every time you go to a new country. You just plug them into the adapter.
Exactly. So much easier. And it makes your code easier to test too, right?
Exactly. You can mock out those external dependencies, create test versions of those adapter classes.
That way, you're not relying on the real external library during testing, which can be slow and unpredictable.
Exactly. Gives you that isolation you need to write clean, reliable tests.
Makes sense. So speaking of testing, we've touched on it throughout this deep dive, but what does a clean test actually look like? What's Martin's take on that?
Oh, he's got a lot to say about testing. He's a big advocate, obviously, but he says just having tests isn't enough.
Okay, yeah. I have seen my fair share of messy tests in my time.
We all have. But he insists they need to be clean, well-written, just as much as your production code.
Really? Even though the tests aren't going to be shipped to users?
That's right. He considers test code just as important.
Huh. Interesting. I'll admit I've been guilty of treating tests as a bit of an afterthought.
It's tempting to do that, but Martin's point is that if your tests are a mess, they're not doing you much good.
Because if the tests are hard to understand, they're hard to maintain, and you're less likely to actually use them effectively.
Precisely. He emphasizes readability, clarity, expressiveness, just like in your production code.
So how do we achieve that? What are some concrete tips for writing cleaner tests?
One thing he talks about is building a domain-specific testing language.
Okay, that sounds intriguing, but also a bit intimidating. What does that mean exactly?
So let's say you're testing an online store, right?
Hmm.
Instead of writing test code that directly interacts with the database or the shopping carts code directly,
Right.
you create helper functions that are specific to the things you're testing.
So instead of writing code to insert a product into the database table directly, you'd have a function called add product to cart.
Exactly. Or a function called calculate total price
Uh.
that retrieves prices, applies discounts, all that stuff.
Okay. So it's about abstracting away those low-level details and creating a more expressive, more readable testing interface.
You got it. Makes your tests so much easier to understand at a glance because you're using the language of the problem domain.
Right. It's like you can read the test and instantly understand what it's trying to do, what behavior it's verifying.
Exactly. Makes debugging a lot easier too.
Oh, for sure. Now, are there any other, maybe simpler tips that Martin offers for writing cleaner tests?
He's a big fan of the one assert per test rule.
And meaning each test function should only have one assertion statement.
Ideally, yes. It makes it very clear what you're texting.
Right. So you know exactly what failed if the test breaks.
Exactly. No more trying to decipher which assertion in a long, complicated test is the one that's actually causing the problem. And he's got this handy little acronym he uses to remember the characteristics of a good unit test. FIRST.
Okay, I love a good acronym. Break it down for me.
So, fast tests should run quickly. You don't want to wait forever for them to finish. Independent tests shouldn't rely on each other. They should be self-contained.
Makes sense.
Repeatable. You should get the same result every time you run the test, no matter what. Self-validating the test should clearly indicate whether it passed or failed. No need for you to manually interpret the results.
Right. And finally, timely.
Yes. Tests should be written alongside the code, ideally beforehand if you're doing test-driven development.
Got it. Write your tests first, then write the code to make them pass. I've tried to stick to that, but it's easier said than done sometimes.
It takes discipline, but it's worth it.
Absolutely. So those are some great tips for writing cleaner tests. Now, we've covered a ton of ground in this deep dive, from naming conventions to error handling to testing. As we start to wrap things up here, what's the one big takeaway you want our listeners to walk away with?
I think the biggest takeaway is that clean code is about more than just aesthetics. It's not just about making your code look pretty. It's about building software that's easy to understand, easy to maintain, and easy to change.
It's about recognizing that our code is not just for the computer to read, it's for other humans to read as well, including our future selves.
Exactly. It's an investment in the long-term health and maintainability of your projects. And ultimately, I think it's about taking pride in your craft, in building software that is not just functional, but also elegant and a joy to work with.
I love that. It's about crafting code that we can be proud of. Well said.
And on that note, I think that's a great place to wrap up our deep dive into the world of clean code. To our listeners, we hope you've enjoyed this journey through Robert C. Martin's clean code, and we hope you'll join us again next time for another deep dive into the world of software development.